Copper in the presence of the halide in Cu2H2O.
No. That was not the method. Tell me.
Sir, with treating carbon monoxide and HCl.
Yeah, AlCl3.
Yes, sir. In the presence of AlCl3 and CuCl.
Yeah. These are Lewis acid catalyst. And you will end up with CHO. Right? And so this is one of the method, and which is determine aldehyde synthesis. This is not the determine which you were telling. That is for diazonium. Okay. That is for the preparation of halides. Right?
Yes, sir. Yes, sir.
But yeah, there also you have a determine. Okay. And this determine is different. Right?
Yes, sir.
So determine aldehyde synthesis is what? Tell me. Yeah.
I don't.
Okay. So yeah, in this also you take HCN plus AlCl3. Okay. And so immediately you will have not aldehyde but something else. Okay, this you react with water, so it undergo hydrolysis and then you get an aldehyde. Is it clear?
Yes, sir.
So this is the way by which you are going to get done.
Sir, can you show the methods of preparation starting one more time? Just note it down.
Which one?
The methods of preparation of benzaldehyde.
Yeah. Clear?
Yes, sir.
But if you want to bring in an aroma and a CHO group on aromatic alcohol, phenol, then what you are going to do?
Sir, remertimine.
Yeah, remertimine. There you have remertimine. right? And this remote even actually, suppose if any one of the ortho position is occupied, then it is going to come at para position.
Yes, sir.
Okay. If normally if you have okay, both the ortho free, then the ortho positions are 2. So ortho actually overpowers para. So ortho product is the major product. But if you have one ortho occupied, and then there will be a competition between ortho and para.
Sir, but
Okay.
generally para will be obtained in major products, right, sir?
Yeah, generally para, it depends actually. Yeah, it depends. So why can't we? So para, it depends actually. Sometimes there is an association with a group at ortho position, then the ortho is major. And if the group is very bulky, then para is major. Is it clear? So you compare the ortho para ratio also. And that is
Yes.
compared for with respect to the size of the group also. Okay.
Yes, sir.
For example, if you have catechol, what you are going to get? So what is going to be the IUPAC name of the product?
1,2-dihydroxy dihydroxy benzaldehyde.
So then that's the common name. Okay. So these are ortho position. So this is ortho of the upper OH, and this is ortho of the lower OH. And these are para position. Right?
Yes, sir.
So one ortho is occupied, so para is going to be the major product, right?
Yes, sir.
And this is going to be the answer. Okay.
Yes, sir. Sir, any of the para isomers, right? The down para.
Yeah, any of the para isomers. Yeah. Or suppose if you have this.
Sir, but ortho it will not come because
Ortho?
ortho the CHO group won't come, right? And the second
Yeah,
ortho.
ortho, it will be a minor product actually.
Yes, sir.
What about this one?
So, para
So
to
what?
OCH.
Para to OCH3, X is Yeah, what is going to be the answer? Yeah, Nabil. Nabil, can you hear my voice?
Will it be option 4?
Yeah, it will be option 4. What you are going to do?
So why are option 1?
No, actually OH is more activating. Got it?
Yes, sir. So OH, because it's more reactive, it will
Yeah.
dominate.
Yeah. Right? But deliberately I have written this at the top. Okay. So this is the most common question. Be careful regarding that. Okay. Clear? So you can directly tell me what is C.
So benzene diazonium chloride.
Yeah. COCN plus KCN or K3COCN. So what's going to be D? And what's going to be E? And what's going to be F? Yeah. Tell me. Yeah, Nabil.
Sir, in the D, it will replace the diazo group with the cyanide group.
Yeah. Correct. So what's going to be the so IUPAC name? Common name is benzonitrile. Benzene carbonitrile, right?
Yes, sir.
And now how you are going to convert it into CHO?
Sir, by lithium aluminum hydride or dibyl H.
What one? Which
Sir,
reagent?
dibyl H. Dibyl H.
Yeah, dival H and H2O. What could be the other method?
Sir, by stannous chloride.
Yeah, Stephen's reduction.
Yes, sir.
Yeah, SnCl to HCl. And what is F? Yeah, tell me.
So, is it radiographs calculation?
No, but already you have one carbon from this to this. That is from benzene.
Yes.
Okay.
Then nitride to ester. To ester.
Yeah.
So, is it
This
lithium
also you
aluminum?
know. Yeah, this also you know actually. Yeah, tell me.
This one is it lithium aluminum hydride?
That is going to give you LiNH4. But how you are going to bring the carbon? Yeah. So how you are going to bring the carbon? Think. So this is CN. Okay. That's the hint.
So,
Okay, can
Grignard
you hear my
reagent.
voice? Yeah, Grignard reagent, exactly. So what you are going to react it with?
Any carbonyl compound.
Yeah, which one you are going to use?
Methyl magnesium
CH3 MgB.
bromide.
Yeah, CH3 MgB. And followed by
Hydrolysis.
hydrolysis, exactly. Right?
Yes, sir.
Okay. So this is all about the preparation. And now we come to the reaction. Okay. So the reactions are of many types. So one is your nucleophilic addition reaction. Okay. So nucleophilic addition reaction, this carbonyl group is polar. Why it is polar?
So, because of electronegativity of oxygen.
Yeah, between the oxygen and the carbon. And the nucleophile is going to come in and join. Right? So
Yes,
this
sir.
is how we are going to have this addition. And normally what you do, you take H plus H2. So you end up with this. Okay.
Yes, sir.
So this is so. Are you aware of any nucleophilic addition reaction? Tell me. On aldehyde and ketones.
The addition formation of cyanohydrins
Yeah.
and then addition of hydrogen sulfide, the formation of hydrogen sulfide. and
Yeah.
formation of alcohols by Grignard reagents, and reaction with alcohol,
Yeah.
and also attack or reaction uh, with nitro group, I think amino.
Yeah. Cyanohydrin, that reaction with ammonia derivatives. Okay.
Yes, sir. Yes, sir.
Ammonia derivative is reaction with NH2Z,
Yes, sir.
right? And let's do some questions, okay? And with that, we can understand it in more detail. So, are you aware of the rate of nucleophilic addition reaction? Compare rate or equilibrium constant for cyanohydrin formation. Who can form cyanohydrin more easily? Compare this, you understood now. This is reversible actually. Okay. So one who is having higher K value, okay, will form more product. Is it clear?
So Ka means
K cyanohydrin means the equilibrium constant for the cyanohydrin formation.
answer for nucleophilic reaction. You said Ka value. Ka means
No, not Ka, actually K cyanohydrin. Equilibrium constant. K is for acids, not for nucleophilic.
yes, sir.
Right?
Yes, sir.
Actually, I wanted to say uh, equilibrium constant value, K cyanohydrin, right? So so compare K cyanohydrin formation, where you're going to more yield, where you're going to get the more yield, and where it is going to be, where which reactant is going to undergo cyanohydrin formation most easily. Okay, that we need to compare. Okay.
Yes, sir.
For example, you have benzaldehyde, and if you have benzaldehyde which is having OCH3, if you have a benzaldehyde is going to undergo, it will undergo the addition of Cn minus. Benzaldehyde with having CH3 group, or benzaldehyde having NO2 group. So what's the comparison of cyanohydrin formation by all these reactants? Where the equilibrium is going to go more towards the product side. I hope you understood the question. Nabil, clear? So if the K is more, you are going to have more yield of the product.
Yes, sir.
And if the K is less, means equilibrium constant is towards the, because cyanohydrin is a weak nucleophile. Okay, so that's why we are talking about K. Clear?
Yes, sir. Sir, is it option 4?
Yeah, fourth is going to be the maximum one. And then, correct.
Option number, I think, 1.
Option number
1. So, because CH3 and
one.
CH3 are electron donating, right?
Yeah, electron donating groups. Yeah, option one, correct. Very good.
Then next one is CH, option 3 and then option 2.
Option three and last is option two. Right. Very good. Option two, because it is doing the resonance, so that is going to be the Lewis reactor. Okay. In terms of cyanoidin formation, right?
Yes, sir.
So this is you need to compare the nucleophilic addition reaction rate. Suppose so, which famous molecule are we going to synthesize by this? What's the common name of that molecule? And how many isomers will be obtained for that molecule? Got the question? So what's the common name of the product? It's very common. And how many isomers you're going to get for that product? Total number of isomers.
Sir, it-
Hmm. Common name of the product, because it is given in NCRT, so that's why I'm asking common name. You need to know it very well. Okay. Because if it is given in NCRT, it can come
sir,
in any examination. Yeah. Yeah. His common name is lactic acid.
sir, what is the
Okay.
formula?
You tell me from the product, you know it. Yeah. Just derive it. You can do it. Tell me. Yeah. What's the formula? Yeah, Nabil. You can derive it. So Cn minus is going to come and join. Okay. So what you are going to get, CH3, CHOH, and Cn. This is the cyanoitin. Up to here, is it clear?
Yes, sir.
And when you do this hydrolysis with excess of water, this Cn is going to get hydrolyzed to COH. Is it clear?
Yes, sir.
Complete hydrolysis. Okay. So what's the IUPAC name of this? Is lactic acid. That is clear now. Do remember this. Very, very important, because what happens is some things, something which are given in NCRT, they can be asked up to any level. Okay, so you need to be very careful regarding this,
So
right?
I don't think they've given lactic acid in the
Pardon?
main. I don't think they've given lactic acid in the main text.
They have asked you to prepare lactic acid
Okay, sir. The questions.
in the exercise. Yeah.
Yes,
Okay.
yes, sir.
So lactic acid, how you're going to prepare? Is it clear?
Yes, sir.
And now the next thing is, what's going to be the IUPAC name? Of the lactic acid. Yeah. IUPAC name you can tell me.
1-hydroxy acid.
Yeah, what?
So 1-hydroxy acid. So
No, no, not one.
acid.
2
2
hydroxy.
2-hydroxy acid.
Yeah, 2 hydroxy. Right. Good. Okay. So I hope this is clear.
Yes, sir.
And but there is one more question: how many isomers are obtained? That's going to be a bit tricky, but very easy also.
There are 2 isomers.
Yeah. How many? 2. Yeah, which 2 isomers? What is the relationship between them?
So one, the OH group is one isomer is as such. Second isomer, the OH and nitro groups will be exchanged.
Actually, what type of isomers are they?
Stereoisomers.
Yeah, optical isomer. They are enantiomers, right?
Yes, sir.
Clear, because there is a chiral carbon. Okay.
Yes, sir.
And there is a one question which is given in Solomon's. Solomon's, you know, na, is a very famous book of organic chemistry for JEE.
Is it, sir?
Okay. JEE book, organic chemistry, Solomon's. And actually, what happened is this question was asked as it is from the book, that book in JEE, right?
Yes, sir.
But this is actually a bit confusing question. Right? So what's going to be the answer? And this is H. Actually, until you know it, you know the answer. Actually, all of them are possibilities. So sometimes they give you difficult things. Okay.
Sir, here the H2SO4 will not oxidize it, or it is just present as like a catalyst.
No. The matter is of dehydration, not of oxidation. H2SO4 exhibit oxidizing character at very high temperature, and that too with very reducing substances like HI and all. So all the options are actually eligible options. Okay, that's what the problem is. So the problem is very tricky, and but they have mentioned one line in that book, and based on that only the JEE has given the question that with 95% H2SO4 and heat, you are going to get alpha beta unsaturated acid. So this is going to be the answer. Okay, but actually you can't predict on your own, right? Because what you do, if you think on your own, what will happen? Suppose you have added CN and OH will form. Okay, that's the first step. But you have H2SO4, concentrated H2SO4, right? And that will let you think one more step ahead. Okay, so you may start thinking, okay, what this H2SO4 can do, and you will have different questions coming to your mind. Okay, so you may think that okay, this H2SO4 may remove water from the alcohol. It can make alcohol dehydrate, or you may think this it can lead to the dehydration of alcohol as well as some partial hydrolysis of CN group to amide. Okay, the third option is also possible that this H2SO4. Remember that we discussed in alkenes. In alcohols, we discussed that when you heat them with concentrated H2SO4, they are going to undergo elimination reaction. Okay, that's what the elimination is. So, but in all second, third, and fourth, in all the elimination of alcohol is happening. But that water which is going to get eliminated, what it is going to do with the CN, or will it keep that group as CN, or will it make it COH, or will it make it CONH2? Okay, that's what we need to discuss. Okay, so this is the answer. Clear? Right?
So the last part in the session about H2SO4
Actually, the water is removed. In alkene, you got alkene. Okay. Right?
Yes, sir.
And the water actually led the hydrolysis of the CN group to COH. Understood?
Yes, sir.
What actually has happened?
Sir, so first dehydration, and then that what
Yeah.
oxidation.
Not oxidation, hydrolysis. Right?
Yes, yes, sir.
So that's how the reaction has happened. Okay, but it is tricky because the options are some cases. In some cases, it happened that all the options are very close to one another. Okay, so you need to know the something. You need to have the prior knowledge to do that. So it can be converted to alpha beta unsaturated acid. It can be converted to beta hydroxy acid, lactic acid. We already prepared. Okay. So I hope this is clear.
Yes, sir.
And suppose if I ask you one more question, then we will move ahead. The isomers of the product which you are going to get in this reaction are, so P and Q are what type of isomers? Structural, optical, are they geometrical, or are they positional?
Sir, but here aldehyde group is not there, right? So then how will the casing have?
Pardon?
So here there is no CHO group, right?
Yes, but it can add up to some extent to ketone also. It will be less, okay. The yield will be less, but it can happen. Got it?
Yes, sir.
Yield will be less as compared to an aldehyde. That is true. So don't think about that. Just assume that it is happening in two products which you are getting what they are. Clear or not? Question? Yeah.
But what are the products? How are the products?
Yeah, actually what will happen? The products are geometrical isomers. Okay. Suppose if you have this methyl pointing upwards, okay, this is clear. And the casein, because double bond was flat sp2, casein can come from the top, okay, and it will make OH or vice versa. Is it clear or not? Are you getting?
Yes, sir.
So these two are geometrical isomers, cis and trans. Okay,
Yes, sir.
so that's how it has happened,
Sir, what are
right?
structural and functional isomers?
Structural isomers, actually you have chain, positional, functional, metamers. We can have one class on isomers. We can discuss that. Okay.
Yes, sir.
In this, right?
Yes,
So
sir.
this is. So I hope you understood this. Okay. Now we have the reaction with ammonia derivatives, which is the other nucleophilic addition. Reaction of Grignard already we discussed, right?
And then addition of alcohols.
Addition of alcohols. Okay. So what do you get when you add alcohols? on aldehydes and ketones.
On ketones, we get ethylene glycol, like structure similar to ethylene glycol, and alcohol we get hemiacetal structures, which on further hydrolysis they give acetals.
Actually, if you take 1 mole, it is hemi. If you take 2 mole, it is not hemi. It is complete. Right?
Yes, sir.
Okay. So suppose so what are these? Tell me. So identify them.
Sir, you should find the IUP's names or
No, not IUPAC names. Just tell me whether they are acetyl, ketal, hemiacetal, hemiketal. Each one of them. Right? Understood the question?
yes, sir.
Okay, good.
Sir, fourth one is ketal.
Fourth one is ketal, right? Very good. On this side, you have 2 carbon, then it is related to ketone. So it will either be ketal or hemiketal. And what else? Tell me. Yeah, Nabil. This one, third one?
Sir, it will be acetal.
Yeah, it is acetal. Good. This is acetal of which aldehyde?
The secondary aldehyde.
Formaldehyde.
Yes, sir.
Okay. Right?
Yes, sir.
And what about this one?
So that will be hemiacetal.
That will be hemiketal. Okay. This is just the ketone, acetone.
Yes, sir.
Look on the other side, 2 carbon. Okay.
Yes, sir. And the first one will be hemiacetal.
Yeah, first one will be hemiacetal, right? Good.
Sir, how do you identify whether it is hemiacetal or acetal?
If OH you have one OH, that's very easy. It's going to be hemi. Is
One
it
OH,
clear?
if OH group is present, then it is hemi.
Yeah.
Okay, sir.
And if no OH group, then it's not hemi, right?
Yes, sir.
Very simple. Okay. So what you are going to get over here?
Sir, can you show how that acetal and ketal formation reaction takes place?
Yeah.
Because in school we didn't learn that yet.
That's very simple. Okay, first tell me what do you think that can be the answer to this problem?
Sir, is it option 3?
Yeah, option 3, correct. They all look same. In dry HCl, what you are going to do, you are going to remove the water. Right?
Yes, sir.
That's it. Remove the water and connect both the oxygen to the doubly bonded carbon atom. Is it clear?
Yes, sir.
And that's how it is going to happen. Okay.
Yes, sir.
And how you are going to break it again? Tell me. How you are going to get back your
Reactants.
yeah, original reactant, how you are going to get it back?
So by adding H plus,
Adding,
like acid.
yeah, you take dilute condition, H plus H2, aqueous condition, right?
Yes, sir. Sir, we can say like by hydrolysis also.
Yeah, this is hydrolysis only. Okay, so you will get back your ketone or aldehyde, whatever you have taken, and your alcohols. If you would have taken two alcohol, definitely two alcohol, or if you would have taken one diol, it will be one diol, right?
Yes, sir.
Okay, and that's how you are going to do it, right? And now next reaction with ammonia derivatives. So what all ammonia derivatives you know?
Aniline.
Yeah.
Sir, aniline.
No, actually I'm talking about those which you react with aldehyde and ketone. Reaction of ammonia derivatives. So reaction with NH2Z. Okay, just ammonia is NH3. I remove one hydrogen and Z. So what this Z can be and what could be the name of this ammonia derivative, and what is going to be the name of the final product? Okay, right?
Yes, sir.
So tell me. Yeah. So what's going to be the answer? General, you know, na? General, how you write? Yeah, Nabil. You take diHCl, you react with this ammonia derivative with the aldehyde and ketone, and what happens over here is the water get removed. Okay, and you end up with this product. If you add water, definitely you are going to get back your the original thing. Okay, it is going to cleave, right?
Yes, sir.
So tell me.
Sir, for this one, by hydrolysis, we won't be able to get back the original product.
Yeah, we will be able to get back the original product. C double bond O and NH2. In some of them, this may break further. So in some of them, you may not be able to get back the original products. Okay, but you are going to get back your ketone.
Yes, sir.
Right? So Okay. Tell me, what the name of this? What is Z, and what is the name, and what is? Have you studied this in your school and Learnivio? Learnivio, is it completed?
No, sir.
Yeah. Okay, it will be taught. Right. Don't worry. So meantime, we can do that. NH2. Suppose if you have alkyl group, this is called amine, right? And the product will be N and R. That will be amine, right?
Yes, sir.
And suppose if you have NH2OH, that is hydroxylamine. The product is going to be known as, okay, this is ox and amine, oxime, right?
Yes, sir.
Is it clear?
Yes, sir.
And suppose if you have Z as NH2, what's it's going to be known as? This is going to be known as hydrazone,
Yes, sir.
right?
Yes, sir.
And suppose if it is, so what you are doing in your CBSE topic right now?
Sir, now we are about to finish chemical kinetics. Then we will do the
Okay.
inorganic chapters. Then afterwards, we will do the remaining organic ones. Which aldehydes,
Yeah.
ketones, amines, and then biomolecules in school. Sir.
Okay. In school or in Learnivio?
In school. Sir.
CBSE batch. Okay. And what is going on in the CBSE batch?
In Learnivio, now we are doing electrochemistry. Today we finished chemical kinetics. Now we are starting electrochemistry.
Okay. Okay. Good. Okay. So it's better that you are actually attacking the subject from two different sides. That's good. Right. So this is what? So that is hydrazine and this is phenylhydrazine. Okay. And you need to, the pattern of making the product is very simple. Okay. So first duty is to know the name. Right.
Yes, sir.
What's the name of the product?
So phenylhydrazone.
Yeah, exactly. The product is going to be phenylhydrazone. Right. This functional group is known as azone. Okay. And what about this one? This is going to be very, very famous. Yeah. Tell me.
Sir, dinitrophenylhydrazine.
Yeah, dinitrophenyl hydrazine. 2,4-dinitro and in short, this is very famous actually. It is known as 2,4-DNP, right?
Yes, sir.
And the product which you are going to get is
2,4-dinitrophenylhydrazone.
exactly. Right. So 2,4-dinitrophenyl hydrazone. Okay. So that's going to be the product. So yeah, why it is so famous? Actually, this is so these are bright colored crystalline solids. So this is used to identify aldehyde and ketones.
So these are like the azo compounds.
No, they are not azo compound. Azo compound have pH N double bond N.
Yes, sir.
They are also dyes, right?
Yes, sir.
They are dyes, right? And uh, these are also colored. So if you have an aldehyde or a ketone, put how you are going to make out. What's the laboratory test? It's 2,4-DNP test. Okay. And the moment you are going to put this, and if it reacts, you are going to get the bright colored crystalline solid, right? So I hope this is clear to you. Okay.
Yes, sir.
And there's a last one among all these. So used to what's the use? Why it used for the identification?
So this like for identifying whether it is a carbonyl group or whether it is aldehyde or ketone group.
Only aldehyde and ketone get the test.
No,
No
sir. Like
carboxylic acid.
yes, sir.
No
Is it
acid
like
chloride. Okay. And the
yes, sir.
carbonyl group CO is there in anhydride, it is there in amide, it is there in acid chloride. Not all
Sir,
those. Only,
sir, it is only
hmm.
to identify whether it is aldehyde or ketone, or to distinguish between aldehydes and ketones also.
Yeah, aldehyde and ketones both will give this test, so you can't distinguish among themselves. But you can use this test to distinguish aldehydes and ketones from rest of the function.
Yes, sir.
Is it clear?
Yes, sir.
And the last one is this looks like urea. Urea is NH2CO NH2. Okay. But it's is NH2 put on urea. Okay. Its name is semi-carbazide, right? and the water is going to get removed. Okay, and remember this nitrogen will not react. This nitrogen is going to react. It is because those nitrogen are in resonance. Okay.
Yes, sir.
So sometimes what they do in NCERT also they have done. Yes. They will deliberately write this nitrogen, this one, in front of the CO, so that you can make the mistake. Okay. So be careful about that. Is it clear what I'm trying to say?
Yes, sir.
Yeah. So this is, you need to take the nitrogen which is farther from CO, not adjacent to CO. So this is semi-carbazide. So this is product is semi-carbazone. That's going to be the answer. Okay, these are all are actually bright colored crystalline solid, but out of these most famous is 2,4-DNP test. Is it clear? Yeah, Nabil, tell me.
How is it semi-carbazone?
The functional group name is semi-carbazone. That functional group name is semi-carbazide. Semi because you have only one side, you have NH2 attached on the urea. Okay. So this is nucleophilic addition reaction. So first N comes and attacks on the double bond O, that get changed to OH, and the water gets removed, and which lead to the formation of a double bond. Okay, these tests are very, very important, very basic, but the drawback is you can't identify whether it is aldehyde or ketone. For them, there is different test. Is it clear?
Yes, sir.
Right. So let's cover it on the next turn with more reactions. Okay, you can go through some of the reactions. Okay, we can discuss them in detail. Okay, this is the most confusing part. Everybody get confused in this. So just have a look at these.